Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We are from Group 6, consists of Rizkya Namira, Falinsa Almayda, Ihsan Fajar, and Salsabilla. So today we will talk about our project. It's about Newton's law, designing a water rocket. First, we will talk about the background theory. A water rocket is a type of model rocket using water as its reaction mass. The water is forced out by a pressure gas, typically compressed air. Like all rocket engine, it operates on the principle of Newton's third law of motion. Newton's third law states that if an object A exerts a force on object B, then the object B must exert a force of equal magnitude and opposite direction back on object A. Or we can simply say that for every action, there is an equal and opposite reaction. And it's also in line with the equation here, that is force of action is equal to force of reaction. And the one of example of Newton's third laws is when the air pushed out of the neck of the balloon reacts the opposite direction by moving upwards, like the picture here. And also the rocket. The rocket will be launched when there is a push as an action from the launcher.
So next is materials. Next. So for the materials, we need two bottles, 1.5 liters, cutter, scissors, plasticine, water, cardboard, tape, and also the launcher. Next, procedure. For procedure, the first one, we have to cut the bottom of the two bottles and attach the bottom of the bottles using tape. Second, make the fins and the nose cone using cardboard. Third, attach the fins to the three sides of the bottle using tape. Fourth, attach plasticine on the top of the bottle and cover it with cardboard. Open the bottle cap at the bottom of the bottle. Fill the water in the bottle and attach it to the launcher. Set the angle of the launcher as follows. First is trial 1. Trial 1 is 45 degree. For trial 2 is 45 degree. For trial 3 is 60 degree. And the last is pump it using tire pump and launch the water rocket. Next. So this is the example of prototype before revision.
Okay, now we're gonna discuss about the result. Next. So this is our first trial, where the angle is 45 degrees and the pressure is 30 pounds per square inch. For the mass is 599, and we got the result for the distance is 10 meters. And you can look at the video. Our rocket goes in the wrong way. And then next, we try again in a trial 2. In a trial 2, we consider about the wind maybe affected our experiment, so we change the direction. For the angle is still same, 45 degrees. For the pressure is 60 pounds per square inch. We enlarge the pressure, and the mass is 575, and we got the result for the distance is 16 meters. And then we try again in the trial 3. So for the trial 3, we change the weight from the gravel to the plasticine because we consider the weight of the rocket water is too light, and so we change the weight to make it heavier. So the angle is still same, the pressure is still same, but the mass is 774, and we got the result for the distance is 42.3 meters. Okay, next. Okay, based on our experiment, we consider about the weight is affecting our prototype. So we change the weight from the gravel into the plasticine, and we remove the cone. And then this is the final look of our final prototype. So the difference is the weight and the cone. And this is the look for the rocket, and then this is for the bike pump, and this is for the launcher. Next.
Then okay, the last is our, and then the last, after we conduct our experiment, we can conclude that to reach the maximum distance, a large force of action is required. According to Newton's law, the greater the mass and the pressure applied, the greater the force produced. Based on our experiment also, we realized that the wind direction affect to the ideal angle that we need, and the pressure is affected to the distant rocket to launch. So we enlarge the angle and give bigger pressure to make the rocket launch optimally. And that's all from our group. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.